Understanding the kinds of outdoor air quality data that are available and how that data differs can help you determine how they may be used. Let's start with the data collected for regulatory purposes. The Clean Air Act directs EPA to limit levels of air pollution in the outdoor air. The agency sets national ambient air quality standards, called the NAAQS, for pollutants that are common in outdoor air, considered harmful to public health and the environment, and that come from numerous and diverse sources. These pollutants include carbon monoxide, ozone, lead, nitrogen oxides, particulate matter, and sulfur dioxide. EPA, states, and tribes place air quality monitors in high population and high pollution areas across the United States to evaluate air quality. These instruments must meet strict EPA or state environmental regulations, both initially and over time. Because our regulatory decisions affect human health and may impose costs to improve air quality, EPA requires rigorous quality assurance and quality control procedures for this monitoring network. These include requirements for where monitors are sited, as well as how samples are collected and analyzed. Regulatory monitors are operated and maintained by trained staff. EPA is confident that the air quality measurements this network provides are accurate. In comparison, air quality sensors can be portable, less expensive, designed to be low maintenance, and require minimal training to operate. So how can we put sensors and their data in context? It depends on your objectives and purpose for measurement. Air quality sensors and crowdsourcing allow for more measurements over space and time. Sensors, for example, may be helpful in hotspot identification, monitor siting, and exposure pattern identification. They can also help inspire behavioral changes and educate people about pollution where they live, work, and play. However, sensor performance can be highly variable. They may provide less accurate measurements than regulatory monitors and may not operate well in extreme environments, like high temperatures, humidity, or pollution. Also, many people operate sensors with limited, if any, quality assurance. Currently, some sensors lose their ability to take accurate measurements over time. Finally, sensors may provide data outputs every minute or second. Note, with more frequent sampling, there can be greater uncertainty in the measurement itself and how to interpret any potential effect on your health. If you're looking at sensor data, you need to ask yourself some questions about what you're seeing and how to make sense of that data. Where can I go to learn about the performance of different sensor units or manufacturers? How will I use the information to inform decisions about outdoor activities? How should I interpret the raw or processed sensor measurements? Are the measurements collected every second, minute, 15 minutes, or hourly? How does this information compare to what EPA shows on air now? These questions are important to consider when deciding how and when to use regulatory versus sensor data. Learn more at epa.gov/air-sensor-toolbox.